Okay, this is Algebra 2, Lesson 34. In this lesson, we're going to talk about uniform motion problems. Previously, we learned that if we have one distance equals another, they could be going either in opposite directions or the same directions. You'd have d1 equals d2. And remember, we have to remember distance is equal to what? Rate times time. Then we learned, a few lessons later, well, sometimes the distance of 1 plus the distance of 2 equals k. And they could be going here, and then one starts here and continues, or they can go in opposite directions, or they can come together to meet. But together, their distances added together equal 1, so you've got d1 plus d2 equals some number k. This example shows 480. Well, we're going to learn another one. We're going to learn distance 1 plus k equals distance 2. So basically, we've got here, we've got some distance, let's say distance 1, and distance 2 exceeds it by some number, k. For instance, it might say distance 1 is 40 kilometers less than distance 2. So here's distance 1 plus the 40 kilometers gives you distance 2. So you have distance 1 plus k equals distance 2. So let's look at example. So basically we're going to have R1 T1 plus k equals R2 T2. Alright, so let's look at an example. This is example 34.1. Millicent began the journey at 6 a.m. at 50 kilometers per hour. Beauregard began to chase her at 10 a.m. at 60 kilometers per hour. What time was it when Beauregard got within 40 kilometers of Mucilin? So, let's change this. We're going to leave this up here as an example. So, we've got D of M and D of B, and this is 40 kilometers. It says Millicent began journey at 6 a.m. and Millicent's rate, so R of M, is 50 kilometers per hour. Beauregard began to chase at 10 a.m. at 60 kilometers, so R of D equals 60 kilometers per hour. What time was it when Beauregard got within 40 kilometers of Millicent? Okay, so here's Beauregard, and here's Millicent. Well, Beauregard got within 40, so this is going to be the 40 here. So basically, we're going to have R of, this is going to be your D of 1, and this is going to be your D of 2. So R of B, T of B, plus 40 is going to equal to R of M, T of M. Now, what do we know? Do we know R of B? The rate? Yes, the rate of B was what? 60 kilometers. And do we know the time? Well, we know they left at 4 hours difference, right? So, who left first? Millicent. So we're going to have T of M equal T of B plus 4, right? So we have 60 for R. Do we know T of B? No. Plus 40. We have R of M, we know 50. And do we have T of M? Yes, it's T of B plus 4. And we've got to distribute this to 50. T of B plus 200 equals 60 T of B plus 40. Oops. And we're going to solve. So we're going to take 50 T of B minus on both sides. And we're going to get, let's right over here and see if we can see this. 10 T of B plus 40 equals 200. I'm going to minus 40 from both sides. So 10 T of B equals 160 divided by 10. T of B is 16. So the time of whatever her name is, B, is 16. But the question asks us, what did the question ask us? It says, what time was it when Bjerregaard got within 40? So that's our answer. It's 16. They want to know when the time of Bjerregaard. Her time, how long, was 16 hours when she got within 40 kilometers. All right? Thus, in 16 hours, Bjerregaard got within 40 hours of Millicent. 16 hours after 10 a.m. would be 2 o'clock in the morning. So they wanted to know what time. You could calculate 16 hours after that, which would be 2 hours. So let's look at another one. These are a little bit tricky because they start with within the within, kind of makes it a little more trickier. But basically you have one distance plus some distance equals distance 2. Alright? So it says, when the sheriff began his pursuit, Robin Hood had already, so we're going to do this. Robin Hood was already 7 miles out of Nottingham. If the sheriff traveled at 6 miles per hour, so the sheriff, so we have Robin Hood and the sheriff. So we're going to have D of R and D of S. Okay? So we know, they said, if the sheriff traveled at 6 miles per hour, so the sheriff, so the rate of S equals 6, while Robin Hood's rate was 2.5 miles per hour. So R of R equals 2.5. Yes. How long did it take the sheriff to catch up? So it said, when the sheriff began his pursuit, Robin Hood was already 7 miles out of Nottingham. So when the sheriff began, Robin Hood was here. He was ahead by 7 miles. So this is 7. So this is D of R, and this is D of the sheriff. Does that make sense? So it said, how long did it take the sheriff to catch up? So they're getting to the same. So there. So when the problem began, Robin was already 7 miles out of town. How he got there or when is not part of his problem. Thus, Robin and the sheriff began traveling at the same time and stopped at the same time. So they started at the same time. He just happened to be 7 miles ahead. So we know the time of the sheriff is equal to the time of Robin Hood. And just a quick little note, when you're doing these uniform problems, you're going to have one of these the same, whether it be the distance, whether it be the rate or the time. We know that the distances are not the same. Okay? We know the rates aren't the same, so the times have to be the same. So even though they didn't tell us directly they started the exact same time, it's implied that they started at the same time. He just happened to be 7 miles ahead when they both started. So we know that those are the same. So we're going to have D of R plus 7 equals D of S of the sheriff. So we know R of R, T of R plus 7 equals R of T, T of T. Oh, excuse me, S for sheriff. Alright, so do we know the rate of Robin Hood? Yes, it's 2.5. So 2.5. The time of Robin Hood, no, plus 7 equals the rate of the sheriff is 6 times, I'm going to make this T of R because they're the same. So then I'm simply going to minus 2.5 from both sides. We get 7 equals 3.5 T of R divided by 7. And I'm going to cheat here. And which is, well, let's see, 3.5. It's 2, 6, 7 divided by 7 over 1. We're going to keep change, flip, and I get 2. So I just, 7 divided by, we're going to divide by 3.5. I did it backwards, that's why. So T of R is going to equal to 2. So the time of Robin Hood, and it asks, how long did it take the sheriff to catch up? 2 hours. Because his traveling time equaled that of Robin Hood, so they have the exact time. So it took 2 hours for him to catch up. So basically, you just have to, this is the hard part of setting these up on these D1 plus K equals D2. Is listening to the wording. He was already ahead 7 miles when they started. So it's implying that they started the same. They give you the rates, so you know the distances are not the same, so therefore the times have to be the same. One of these three has to be the same when doing these uniform. So that's just a little insight and little something to just remember when you're doing it. One of the three has to be the same. So he was 7 miles ahead, so 7 plus his distance is going to give you the distance of the sheriff. And then you simply plug in what you know and then solve for what they're asking for. They happen to ask for the time of the sheriff, which we look for the time of the Robin Hood, but we know they're the same, so the time of the sheriff was also 2 hours. Okay, the code for this lesson is 765 on the top of lesson 32. On the top of lesson 32. Okay?